talking about polynomial division. So yesterday we looked at the actual division algorithms. Or long division or synthetic division. Again, long division is a little more general and can be used to do more stuff. But synthetic division, which only works for linear factors, but will pretty much take care of everything that we need it for. So if you like one of those better, then stick with that. If you want to do a little bit of both to kind of get a feel for it, then you can do that as well. I did go look like more closely through the homework, and it does about half and half. Like some of them, the sort of guidance stuff is talking through long division, and some of them it's talking through synthetic division. But again, you can use either because everything in there you're talking about linear factors. And then the real reason that we care is because of the factor theorem, which says that if we know a zero, then we also know a factor. And more formally, it's something like x equals a is a zero if and only if x minus a is a factor for some polynomial. So if we know a zero, then really we know about a factor. And if we know about a factor, we can factor things that we wouldn't be able to factor otherwise by actually dividing, right? So take that factor that we're given and use that to divide. So I sent you home and said do parts B, C, and D on number 1 in the notes. Are there any of those that we want to take a look at? D? Right. Okay. So for those where it's just like, hey, divide this thing, right? You're not going to know for sure like whether it should have a remainder or not. For the problems where I said this thing is a zero, then the remainder's got to be zero, so it kind of checks itself. These the remainder could be zero, it could be something else. You said D. Okay. Oh yeah. Okay. That's a good one. A thing happens there that I wanted to talk about anyway. Over x minus 3. Okay. Do we want to do long division or synthetic, or do you care? Do I get to pick? Synthetic. Okay. I mean, that's probably what I would choose as well. One thing to notice here. X cubed minus 2x squared minus 9. There's a missing term in the middle, right? There's no linear, there's no degree 1 term here. In other words, the coefficient on the linear term is 0. Now, when we do long division or synthetic division, that doesn't mean that no linear terms are going to show up anywhere in the process. So we have to sort of account for that, meaning I need to like leave space for it. So when I set this up to do synthetic division, I'm going to take the coefficients from these, and again, sort of preserve what they are by the order I write them in. So x cubed, x squared. Then where the linear term ought to go, I'm going to put a 0 as the coefficient, right? So that I'm still sort of taking care of the fact that that exists. Keep in mind that like when you do synthetic division, you're taking the coefficients off. If you omit this, then how am I to know that we're not doing that division rather than the one that we actually want, right? There's nothing to sort of hold the place. So missing terms need a placeholder. That would be that, treating their coefficient like 0, just like you would for a quadratic formula. Okay, and then leave some space and put a little line thingy and 3 here. If you've already done it, great. If you haven't, take a second and do that division. Okay. Somebody walk me through it. Okay. Adding down the columns, 1 plus nothing is 1. Then multiply those. 3 and 1 is 3. Store that in sort of the next slot and then add, right? Repeat the process. So -2 and 3, 1. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. And that leaves remainder 0. So to do this with long division, x cubed minus 2x squared. Again, my advice would be to actually write in plus 0x, where that sort of missing term is. And then we want to look at, leading term into the leading term. So what do you need to multiply x by to match x cubed exactly? Okay. Then multiply x squared times the divisor. Yep. For long division, you subtract. So x cubed minus x cubed, which is good. Again, like that's what should be happening. The leading term should be dropping off at each step. -2 plus 3 x squared. Again, I'm going to actually carry down the 0x just as like a placeholder, right? You can do this by just sort of leaving a space for things if you want, but I think it's probably better to actually write it in. And then repeat, right? X into x squared would give us x here. X times x minus 3 would be x squared minus 3x. And now you see why I wanted that placeholder in the ones place, the degree 1 place. 0 minus -3, so 3. And then x goes into 3x 3 times. Is 3x minus 9. And we subtract and get remainder 0 again. So either way, what we learn is that this x cubed minus 2x squared minus 9 divided by x minus 3 is x squared plus x plus 3 with no remainder. This was just, the actual question here was strictly do the division, but if we were trying to find zeros for that cubic that we started with, that none of our other, factoring tricks and stuff work with, what I just learned is that I can factor it like this. And if I can factor it like that, then I get 1 0 is x equals 3, and the others come from that. Right? Okay. Questions about that one? Pretty okay with, and again, like either of these is fine, whatever you're more comfortable with. Long division always kind of feels like it takes a little bit longer, but sometimes that clicks better for some people. On like a test where you're timed, you're gonna have to do it, exactly one time. So the time thing shouldn't be a huge issue. It's not like you're gonna be doing 6 of these or something. So, 1 minute versus 2 minutes couldn't really be a big deal.
So you would write the answer for that one, x equals 3, x squared for the rest.
So the actual question was just do this division. So the answer would be this. Yeah.
So for like 2, 3, and 4, it says find the zeros. Do we just list the zeros, or do we have to put it in like the form, as a form?
Yeah, so for 2, 3, and 4, since it's find the zeros, you start by doing the division to factor it, and then you would, actually solve. So your answer is going to be, x equals 5 and 6 or something.
Yeah, I'm saying, like, did you want us to put it in like the parentheses, like how we did last week?
Oh, it's not an inequality. So you don't need to like write it in like interval notation. It's just, listing the 2 points. I guess all of them will end up having 2 points. Yeah. Okay. Okay, cool. So we feel good about like doing the actual division. Yes? Okay, cool. All right, well, let's take, 15 minutes, something like that. If you haven't already, we did 2 together yesterday, right? I mean, problem 2. We did, and like we actually finished it. I don't remember. Okay. So if you haven't already, if you have, like, cool, good for you. But if you haven't, let's take 15 minutes or something. Y'all work on 3 and 4 together, and we'll talk about maybe one of those together here in a bit. Again, that's kind of the basic idea. You're given information about a zero, that means you know something that divides in, do the division, use that to factor, and then finish solving.
I got that part.
See, so what you do for, multiply whatever you experienced by this.
Here's that one. There. And then
Yeah, okay, I'll do that. But you next is 12 and that's not it. But I just.
okay, then you're gonna do 0. But no, this is
You just need to do that. Should I just simplify it? And then that's just a zero.
So then that's good.
Ugh, I don't like that.
That means something was wrong somewhere. Right, so like first synthetic versus that was that using back.
okay. Beautiful. But it's better than what it is.
And that's just gonna have to do. I was thinking, I guess we're gonna make those. That's right. Oh, wait. Wait, no, we can't. Okay, five, four, two, so that's it. But I think this has to be, this has to be the, like, two.
I think so.
Would I still get it right if I wrote it like this instead of like that? Or can you say- Do I have to do that? Do I have to simplify it with them?
Oh my God, has questions and questions and something.
I read a pony.
It's okay.
It's all right. You mess with that.
Ignore this, ignore the square root of 3.
And
Think about how you would reduce that.
there's no like 2 over 4, like 1 over 2. Like that.
So now we're left with 10.
Well, I'm gonna look like I didn't do that. I'm gonna put it right down.
So that's the value that we measure. Then be that when you do division, you get x squared and 5x plus.
You have those.
5x. Yeah, and like these are the coefficients. Yes, okay.
Yes, thank you.
Are you doing right? Okay, yeah, I think that one is a vector. Right. Yeah. Feels like. Right, yeah, I think I believe that's right. It doesn't factor though, so go to something else to solve it then.
Don't let it bleed and sit for these values. I skipped that one. Wait. Yes,
Yeah.
can't do that. Then I need to.
No, I didn't even use the touch word, I just put like a teeny little gift background like that.
Squared as well, it's not a perfect square, but not simple. Simplify it.
You wanna help me more about it? No, I don't know. Because I'm in the final exam. Nothing to tell you.
Wait. I have a question. Do you just put zero even though it's the same? There's not a why did I put it on? Yeah.
Okay. So 3 is a 0 of this thing. We need to divide. Excuse me. Because I don't want to have to write stuff, I'm just going to do, or I don't want to have to write as much stuff. I'm going to do synthetic. I don't know if I said this yesterday or not. I think I probably did, but 3 classes, I never know who I told what. The solutions that I wrote up to put in Blackboard, I did like half of them with synthetic and half with long division. So there should be plenty of examples to kind of look at of either, whatever you decide you prefer. So just, kind of quickly, 1 times 3 is 3, plus 2 is 5, times 3 is 15, plus negative 11 is 4, times 3 is 12, leaves remainder 0. Somebody asked Emma maybe earlier about like, how do we know if the remainder is right or not? And I talked to at least one, group of you guys that said like, we didn't get remainder 0, something must be wrong. And you're right. If you didn't get remainder 0, something must be wrong because either I'm lying to you, which I'm probably not because, I checked the problem 100 times before I put it on the test. Yes, sometimes, but I have been wrong about this specific thing before, so now I'm like hyper focused on it. So either I'm lying to you, which I'm not, or something went wrong, either in the way you set it up, right? So first thing to check would be just making sure that you actually copied the coefficients down right, because that can happen, of course. That if you've got the 0, that the thing you're dividing by is correct. For long division, you would be dividing by x minus 3. For synthetic, you just take the value of 0 itself. That feels a little backwards. And then the other thing would be just, little arithmetic thing. The problem is that it's really hard to catch your own dumb little arithmetic mistakes, right? Like if you need to do 3 times 2 and you wrote down 5 instead of 6, like for some reason when it's your own handwriting, you don't notice that stuff as much, right? It's harder to pick that out. So it's probably quicker to just chuck the thing and do it over from scratch, right? Than trying to figure out what the mistake is. In the absolute worst case, that you just can't find it, you can't figure out what's going wrong, you're getting remainder 1, but like the math isn't mathing, right? And you can't fix the mistake. The thing to do on a hypothetical test question like this, where the question was find the rest of the zeros, do you think that your best case for partial credit is sort of a halfway but wrong division thing and then to just bail on the problem? Like probably not, right? I mean, you did half of the problem and you did it wrong. So don't just, run away, but like say I got this and I came out with the remainder 2 and I just can't fix it for whatever reason, right? Like it's the test day, I'm stressed anyway, I can't make it work. The thing to do at that point would be to say something like, you know, I know this is wrong. But here's what I should do next, right? And what should we do next? Well, okay, yes, but we've redone the whole thing. We can't fix it. Like something's going wrong. I don't remember part of how the algorithm works, or my brain is programmed to 3 times 2 is 5 that day, or you know, like whatever is going on, I can't fix it. Assuming we can't fix it, where should we go from here? Just where should we go from here, period, yeah.
Just set it up. Because you know that it's supposed, your remainder is supposed to be zero.
Okay, so where do we go from there? Like, what's the next? X squared plus 5x plus 4 equals 0, and then solve that, right? And you get -1 and -4? Okay. So even if something went wrong in the division part, and like you know it, because the remainder ought to be 0, but it wasn't, but you can't fix it, still go ahead and do the next thing, right? This part is going to be, I don't know, half-ish of the credit. So if you just get here and say, well, I guess I'm just going to be wrong here, right? That's going to hit a lot harder than if you go on and try to solve the thing anyway, right? So I guess the upshot, you know, the point is just keep in mind that like I'm a human grading your stuff. So the worst that can happen when you make some kind of appeal to partial credit is that like I don't agree with you and you don't get it, right? But I can't give you partial credit for something you didn't do. So just something to keep in mind. For the record, this is not actually wrong, right? That was about the hypothetical. We got a remainder too and couldn't make it work. Okay, everybody good with that? Yeah, okay. This factors as x plus 1 times x plus 4. So if you're going to factor it, you want a pair of numbers that multiply to 4 and add to 5. 4 times 1 is 4, and 1 plus 4 is 5. So that factors like this. And then if you split the factors up, we get -1 and -4. Or if you don't want to factor, use quadratic formula and it should go, you know, quick-ish, right? Yep. Everybody else good with that? Okay, cool. All right. And 4, again, similarly, we've got a 0, 2, 8. Well, actually, yeah, we got time. 2, 8, -11, -5. So the quotient (2x squared minus 2x minus 1). Everybody get that? Yeah, okay. Cool, we want to set that equal to 0 and solve. Again, starting with what we started with, that -5 was a 0. We should be expecting that the remainder comes out to be 0 when we do the division. It was, that's good. Again, the chances of me goofing something up in the middle here and still getting a remainder 0 are almost nothing, right? Like it'd be very difficult for that to come out. So this is a good sign. Set it equal to 0 and then solve. Now, as many of you discovered, that one doesn't factor. So again, for something like a test setting, even if you are comfortable with if you're not comfortable with factoring and you're doing everything with quadratic formula, that's fine. Like proceed, make sure you can do it kind of efficiently. Otherwise you might run into some time issues. But even if you're comfortable with factoring, don't spend more than, 30 seconds or something trying to think through whether it factors or not, because maybe it doesn't. And you're just kind of spinning your wheels then. So I might look at this and just see the leading coefficient and go, no, thank you. I'm just going to go to the quadratic formula. Or even if I'm comfortable with factoring, can I find things that multiply to -2 and also add to -2? No, so not going to work. Quadratic formula here, -b plus or minus b squared would be 4 minus 4 times a times c over 2 times a. So that becomes the square root of 12 over 4. 12 is not a perfect square, but 12 does have a perfect square factor. So how else can we write the square root of 12? Yep. 2 squared is 3. And then because I see lots of even numbers, we can actually reduce that. If you don't have to split it up as 2 separate fractions, if that helps you see how to reduce it, then do that. If you're comfortable with it anyway, then you don't need to. But 1/2, well, actually, let me write it both ways. 1 plus or minus √3 over 2, or 1/2 plus or minus √3 over 2. Those are the same thing. They mean the same thing. I'm drawing this line in the middle because I'm cool with either version of this. If one, helps you do the simplifying better, then go with that. We need to reduce this fraction. 2 over 4, 2 over 4. Those things all reduce. The way that you do the reduction is that you need to, treat the two terms in the numerator as though they're kind of separate things, right? So 2 over 4 reduces to 1 over 2. You need to do that in both places. Or you do something. 2 times 2. 2a. This 4?
Yeah.
B squared. Okay. Okay. Any other questions about, the thing in general or this part of it? Okay. Yeah, on something like a test question, I mean, you probably expect this, but, I'm probably, the thing I'm trying to test here isn't necessarily like full on, sort of icky solutions, right? In the division problem specifically. So the division kind of thing, I'm, maybe expect things to work out a little more nicely, but we should certainly be comfortable with this kind of thing. Okay, we feel good about stuff? Okay. So here's at least a partial list of stuff that we've talked about to expect on test 2. Quadratic functions. We need to be comfortable with finding a vertex. Finding intercepts. Hang on, I've forgotten how to spell. Interpreting so given some function that models, what was the thing we did in class? Quarterback throwing a ball, yeah, right. Juggling football. That kind of thing, right? Interpreting what the vertex tells us or what the x-intercepts tell us, all that kind of stuff. Interpreting means, translating a math fact into an English statement using some kind of context. Completing the square. Solving equations and inequalities. Which we've been, using kind of three different, tools to do. Factoring, square root property, quadratic formula. To find the vertex. Remember, if we've got standard form, then we can use that negative b over 2a thing to get the x value, and then you plug it back in to get the y. If you've got it in the sort of vertex like form thing where we can see the transformations, you can just find it by thinking about those. Or you could complete the square to get there, but negative b over 2a if you got the standard form thing. And then the quadratic formula, which surely is seared into your memory at this point anyway, but those two things in orange will be printed on the test. So you don't have to do the, brain dump thing where you scramble to write that down as fast as you can before even writing your name. I'm confident that you could do that if you needed to, but it will be on the test. Okay, that's quadratic stuff. Let me finish the list and then we'll come back to anything y'all want to talk about. That's been about half of our time since the last test. Polynomials. Graphing stuff. So I'm saying graphing. What I mean is all of the information that we, can learn about the graph from looking at the function. So degree, leading coefficient, in behavior, zeros, multiplicity, all of that stuff, right? So we did that quiz problem yesterday. I gave you a graph and asked you to sort of find all this information from looking at it. It's all kind of sitting right there as long as we know what to look for, right? So that stuff. And then again, solving equations and inequalities. Greatest common factor. Factor by grouping. All those factoring technique things we looked at last week. Quadratic form. And now division. Right, factoring when none of the other stuff works by dividing. Okay, listing all the stuff out, I know it looks like a lot. There's, I don't know, 8-ish questions or something. So stuff to, expect. Number one thing that you want to make sure you can do, eyes closed and, in the dark or whatever, is being able to solve a quadratic, right? That's going to come up kind of a lot, both when you're just asked about it directly, like, hey, here's a quadratic equation, solve it. Or, it also kind of comes up in the context of doing these things. Look back at places that we took a cubic and factored it by grouping. You factor by grouping, you end up with a quadratic that you still need to solve. Division, you divide, but then you end up with a quadratic that you still need to solve, right? So probably in doing, 8 problems, I think it's 8 on the test, you're probably going to end up solving a quadratic in at least half of them, right? Because that's just kind of, where we are right now is being able to do that. The polynomial graphing thing, I mean, y'all have hopefully picked up on the fact that, I like the thing where, you can get a bunch of information from a graph if we know what we're looking at and know where to find it. So, certainly expect to see that kind of thing. Some of this, a couple of these things, like finding a vertex or completing the square, we spent a lot of time with, but it was 3 weeks ago or something, right? So make sure to kind of revisit that and make sure that's still fresh. Is there anything else here? We got about 5 minutes left. Anything that, we want to take a quick look at? Uh-huh.
That's going to be primarily in one division, ones or synthetic ones.
You'd be able to do either one. Yeah, so the thing to expect there is something like those last 3 on the notes from this week. I give you a 0 and ask you to, tell me what the others are. Because that to me is a good sort of conceptual question, right? It's showing like not only that you can do the technique, the actual division, but also that you understand the context of, okay, why do I care about doing the division? So yeah, you would be able to do either method though. Yeah. The something like that, maybe, where, the actual degree is 4, so it's actually not quadratic, but I can treat it kind of like a quadratic and factor it the same way, only instead of x plus 2 and x plus 3, I would need x squared plus 2 and x squared plus 3. Yeah, so using that sort of, structure to it. Yeah, or quadratic formula, but you're solving for x squared. Yeah, either of those would work to do that. Yeah. Anything else for now? Okay, well, you have plenty of things to keep you occupied. Practice problems in reviews,